My name is Philip Ivey. I am a University of Rhodes contract staff member, but not based in Makanda, hence why you don't see me that often. But when I see you up in Makanda, it's great to be here. And so thanks very much for having me for this event. I'm going to talk a little bit about a project that we're working on in the Northern Cape. Another reason why you don't see too much of me in Makanda is most of my work is in the Northern Cape. And it's dealing with a thorny problem. The thorny problem actually happens to be a real thorny problem, a plant called Prosopis, which was introduced into South Africa in the late 1800s. Is this going to go down? Does it move to the next one? Not yet. Okay. All right, and my presentation is going to follow roughly those 4 stages. And I say roughly because it is going to be very rough in terms of looking at the problem, looking at previous approaches, and an attempt that we have made to change our approaches and how we've progressed to date in terms of those approaches. The dream when Prosopis was introduced into South Africa was that every waterhole in the arid environment would have a Prosopis plant which would provide shade for livestock and pods for grazing, pods to help fatten up your livestock before they went to slaughter. Unfortunately, the nightmare is this. Prosopis fills up all the low-lying areas with very, very dense invasion of Prosopis, so much so that the number of pods that are produced is reduced because of the density of the plants. Access to the pods is greatly reduced because of the thorny nature of the plant, and animals can't get to graze them, and there are other knock-on effects in terms of water availability and access to grazing and biodiversity in itself. So Prosopis is mostly in the arid areas of southern Africa and spread over 4 or 5 biomes to a greater or lesser extent in South Africa. And we've mapped Prosopis over a number of years. This is a map from the South African Plant Invader Atlas. But you will see, and this is probably not a very clear picture, it is very much restricted to the watercourses and the pans where water accumulates in the arid areas. Sorry. One of the big problems is that unlike indigenous thorn trees, formerly acacia, but Burchellia and Senegalia, the Prosopis has a very, very long taproot. It can get up to 50 meters deep, which means that it can get into the groundwater, and it really damages the water availability when it becomes a dense thicket. Don't get too hung up about the details of this picture. This just shows that there have been community engagements since the 1800s. The first community engagement was the initial establishment of Prosopis. The departments of forestry in the then Cape of Good Hope and the Transvaal Department of Forestry actively encouraged farmers to plant the plant. And then the next series of community engagement was, oh my goodness, we created a problem. And there was, from about the late 1970s, there was researchers from the Agricultural Research Council, or the former Department of Agriculture, and they did a community engagement. They sent out postal surveys, they got back postal returns, and up to 50%, just over 50% of respondents said, we want this plant gone. For various reasons, the biological controllers didn't actively target the whole plant. They targeted just the seed production side to try and reduce the numbers of plants germinating in the environment. And by 2001, already 20, 40 years later, we still hadn't got on top of the problem. In 2001, they were very optimistic that they would be able to get onto the problem, on top of the problem, and by 20 years' time, so 3 years ago, the invasion would be under control and deliver sustained benefits. Not the case. Now we're going to come back to this slide, or a different slide on the same series a bit later. But important to notice is at the bottom there is the invasion extent of the plant. 127,000 hectares in 1974, 480,000 hectares in the early 2000s. So the second stage of community engagement was trying to keep the value of the plant, the pods, without destroying the plant completely. Lots of research done during the 2001 to 2020 stage, but much of that research was treating the landowner as the subject of the research. And it wasn't where the researcher and the landowner were working together to solve the problem. And that's what we've been trying to do in more recent years. So we carry on the time series, and we'll just skip right the way through to 2017, when we started with a new approach, engaging farmers more actively in the decisions around management of Prosopis. And it's the last bit of this diagram, which is when I became involved and the Center for Biological Control at Rhodes University became more actively involved. Just a point to notice, in about 2010, there was so much concern about whether we should be conserving the plant's attributes and not introducing biological control that would damage the whole plant, that the biological controller said, "Andiazi, we're not going to carry on." And there were funding issues at the time as well, but that is the milieu of the biological controller. They are trying to do what the landowner wants, or what they perceive the landowner to need. And we're now at our present community of practice, which I'll talk a little bit more about. Sorry, did that pull up a photograph of their people? Okay, I failed to mention the fact that the Northern Cape, our study area, is the most sparsely populated of provinces. I think there are more sheep per square kilometre than there are humans. And that creates a whole lot of difficulties with engaging communities. We've tried to overcome that with various WhatsApp groups, various meetings, and we have got people together to meet. One of the other difficulties is myself and all the researchers are not based in the Northern Cape. So what we tried to do was to get a champion in the Northern Cape, and we had a master's student who joined us under COVID who was based in the Northern Cape, and she was responsible for facilitating these meetings. The first meeting that we had was in July 2022, and that was already a long way into her master's. We had done a lot of communication, getting people involved. And at that meeting, the farmers said, and I'll say it in Afrikaans, "Ons vergader en jy bring net goggas, goggas, goggas." And I don't know how many of you understand. There was obviously a bit of laughter so that people understood that we meet and all you do is bring bugs, bugs, bugs. And that is the situation. So these other two meetings was a direct response to that concern. They are wanting us to do more than just biological control. So I'm going to have to speed up. In the 2017s, or in 2017, Ross Shackleton, who worked up until that point on a PhD, identified 4 different approaches to managing Prosopis. I'm not going to go through the detail of the top 2 or 3, but the bottom one is where not only are you bringing in new biological control agents that are damaging to the plant, but also increasing mechanized harvesting and utilization of the biomass. And we've worked with don't worry about the detail of this. We've worked with the landowners to develop a theory of change, and we're focusing on 3 main steps in the theory of change: development of farm-scale management plans, more mechanical harvesting, and then improved biological control. So the community of practice has firstly looked at a national strategy for Prosopis based on Ross Shackleton's work. We've also looked at guidelines for developing control plans at farm scale. And we had hoped in the national strategy to include a target that would engage the landowners to commit to drawing up farm scale plans for management of Prosopis and other invasive species on their property. So in terms of farm scale planning, interestingly for us, we had the opportunity to employ the person who did the original work back in the 1980s on managing Prosopis, and he is managing a consultancy now and worked with the farmers then and is now working with the farmers now and developing the farm scale plan. And quite often the farmers are very despondent. I mean, let me just run you through this. This is a farm just outside Brunfley in the Northern Cape, and although it looks green, the Prosopis is the tall tree, and in between the Prosopis you can see very little grass and low amounts of vegetation. And the only fodder that would come from the Prosopis is the pods in that environment. We worked with, we had the target of having 30 farmers to start with to develop these farm scale plans. I think we've ended up with the maximum of about 15. There was a real low response to what they had requested, and we still have to resolve that. But some of the reasons why they were concerned about developing the plans is they tend to focus on very dense stands, and that results in a great deal of despondency. We can't get on top of this problem. There is a very negative perception of the government-funded program in the areas. Many farms across the Karoo have reduced their labour numbers, and labour have moved to towns, and quite often it's a farmer, or quite often a farmer's wife, who is the only person on the farm with maybe one or two labourers. So the ability to manage Prosopis, which is very labour intensive, is greatly reduced. We've also just come out of a 7-year drought cycle, and often the value of the land is less than the cost of clearing the land, which is a major issue. So getting engaged in farm scale planning has been quite a challenge and for us to get them involved and work with the farmers. Even though Graham Harding has been out there and patiently waited at times at the farm gate, he has been stood up on times. We looked at Prosopis biomass use. So this is really outside of biological controller's comfort zone, using the Prosopis. But the farmers are using it as a drought fodder, or when they are wanting to clear the plant, they will offset the expense of clearing using firewood, charcoal, and then we started exploring the value of biochar, and we are exploring the commercial utilization of biochar, which has got huge implications in terms of carbon fixing and reduction of irrigation costs and fertilizer costs if used appropriately. We've also got some crazy engineers involved in the program, looking at syngas, which is taking the wood and through a process of pyrolysis, turning it into gas and generating energy. And in the bottom right-hand corner is something that we're quite excited about, where we've proven that we can use Prosopis biomass in biomass insulated concrete buildings. And that building that one of our mad engineers is standing in front of is a building that's been made out of Prosopis biomass. So apart from some of the steel structures, just to give it a degree of rigidity, that building is entirely made out of biomass and the bonding agent. In terms of biological control, so I pointed out that we have been involved in biological control is at 5. Initially the biological control focused on seed eaters, so that we could have the value of the pod. And this little agent here, an insect called Algorobius prosopis, under the right environmental conditions can eat up to 90% of the seed. Unfortunately, the right environmental conditions don't exist right across the environment. And if you're getting 10% growth, even if it's episodic, so each flood event you get a 10% growth, you'll very quickly spread over a large part of the larger and larger parts of the environment. And even though the insect does lay its eggs on seed in the dung and can damage the seeds in that way, we were still getting a spread of Prosopis. There were two other insects which were introduced which weren't as successful, both targeting the dry seed. So from about 2010, there was a decision made to start working on the leaf tying moth, which had already been introduced into Australia and had been quite successful in very high temperature environments where there isn't a great fluctuation in temperature. So if you imagine Australia on the north west coast, in the Pilbara region, where you've got the ameliorating effect of the ocean, you don't get great fluctuations, but you get very high temperatures mostly throughout the year. We're concerned that this insect won't do as well in South Africa because we don't have the ameliorating effect of the ocean with the cold Benguela current, and the fluctuation might be too great for this insect. We've done a whole lot of climate matching and all the rest of it. This insect was released in 2021. We're still not certain whether it has survived over the winters, and we are still waiting to confirm that it really has established. I'll answer all questions about host specificity afterwards. The advantage of biological control is that you can use facilities to mass rear these species in captivity. So we have worked with the Association of and for Persons with Disabilities in Uppington to set up a mass rearing facility similar to the facility at Wynneck and the one at Kariga. But this is a very much more direct relationship with the Association of and for Persons with Disabilities. And January this year, we introduced the first leaf tying moth into captivity, and we're hopeful that if we are able to secure funding, that we will be able to release insects from that facility in spring this year. The buildings that I showed you that were half complete are the buildings in the bottom left-hand corner now. We transported two buildings up to Uppington, and they are there in place. Wheelchair access, grey water recycling, the whole number. They're incredibly environmentally efficient. And we are hoping to create jobs, meaningful jobs for the team that are featured in that photograph as well. Now, biological control, you say, isn't it going to reduce the biomass that we are hoping to harvest? The intention of biological control is not to eradicate the species. We never will eradicate the species. The intention of biological control is to reduce the species to tolerable levels within the environment. And we're hoping that with the leaf tying moth, another little weevil that we have introduced, which I haven't talked about, and future research on more damaging biological control agents, that we'll get to the point on the right of the graph where the population of plant has decreased, as has the population of the insects. All of this is being done very much more in collaboration with the landowners. You saw those photographs of us on the road show, and part of that roadshow was to spend a weekend with a farmer. So he was invaded by 2 engineers, an invasive plant specialist, and myself, who kind of straddle all of those camps. And needless to say, we drank a bit of red wine, and the following night, or the following morning, the farmer said, "Now this is a real community of practice." And that's where we would like to be. Unfortunately, there are 3,500 farmers in the area, so we can't do the same. My liver wouldn't cope. But that's where we hope to be with the work that we're doing. So thank you very much. Sorry, I started without you.
Thank you. I'm also sorry I went to a wrong vein.
You can administer questions, keep them quiet.
Quite old. Okay,
Yeah.
thanks so much for starting without me. Any questions or comments, colleagues?
Yeah, sure.
One, and then I saw another one here, I think. Oh, I thought you were just scratching yourself. Okay, is that just yours?
Don't know, I will cover questions for everyone. I have 3 questions.
Wow.
Okay,
okay.
there you go.
Thank you so much, Prof. That was very, very wonderful. Yeah. So I have 3 questions. The first one is, why did you choose to focus on Prosopis only in the Northern Cape? Like, is it the only species there that is invasive? And secondly, does this species have seed banks? If yes, do you consider secondary invasion for the plant, and how do you deal with secondary invasion after producing or like introducing this biological control?
Okay. That's 2 questions. Do you have a third?
It's seed bank. The second one is seed bank, and secondary is like it's included to secondary.
Okay, secondary one.
Yes.
All right. Actually, I mean, you hit a sore point. I stumbled onto this project. The Center for Biological Control here at Rhodes University has great expertise in cactus management and great expertise in waterweed management. And in initiating the work on with the agricultural union in the area, the farmers, I wanted to promote cactus work because we are very conscious of the fact that there are a large number of cactus invasions in the Northern Cape. And that graph, or that map that I showed you with the red and pink and density, is the Southern African Plant Invader Atlas. And if you go onto that for cactus, you will find that there are localities for cactus invasions in the Northern Cape, but all of them are along roadsides because that's the nature of the atlas. Many of the farms are 30 kilometers from the road, and we don't have information on cactus invasions, even though we have good biological control agents. So I phoned the then head of the natural resource management of the Northern Cape Agriculture. And I said, look, I want to come and talk to you about our ability to manage your cactus invasions. And they said, no, you can come and talk to us about cactus invasions, but you also have to talk about Prosopis. So Fritz Haystack, who did the work on the leaf-tying moth, I said, please come with me. And he was at that stage with the Agricultural Research Council. We went there in July 2018, and then the focus was, you will only work on Prosopis. That said, we are very conscious of each time we talk about Prosopis, we also talk about cactus, but the signs were coming up here that I couldn't talk about cactus. In terms of secondary invasion, yes, there is a degree of soil stored seed, but the episodic nature of events in the Northern Cape is that there's mass germination after a flood event, and if the seedlings survive, they will grow into invasion. But subsequent to that, if we are able to destroy a large number of seeds, we will start reducing that. But again, if we're leaving 10% of the seeds in the environment, that will always be being replenished. So that's why we're looking at species that will damage, species of agents that will damage whole plants, so natural enemies that will damage whole plants, and natural enemies that will damage seedlings as well. So that is where we're trying to get to with regards the ongoing invasion of Prosopis. Yeah. Any further questions?
Any further question or comment?
I just
to say that was a very good presentation. What is your comment?
we did a whole lot of I would say awareness raising marketing videos that we developed so that we could send them out to WhatsApp groups, communicating with a farmer who lives 30 kilometers from a main road down a very difficult gravel road and might have limited access to electronic communications. Yeah, it's easier than it was in the past. Interestingly enough, our surveys using electronic media and social media yielded less response than the postal media. But if we were to try it on the post now, we'd still be waiting for responses. So it's trying to get the balance right. Yeah, but we persevere.